Welcome, Professor and YouTube. So this is for an assignment to do with heart disease. So the question is to create a bespoke algorithm that beats table 11 from the paper listed on the screen. So let's talk about it. Random forest. What I did is bring the time variable back into the data, and this is the model. And what we get is an MCC score of 0.645. So there you go. It automatically beats the model. But of course, we can't just run random forest and then call it a day. It has to be bespoke. So what I plan to do is do a hard voting method. And so we need to know what features are the best. So the top features is time, serum creatinine, and ejection fraction. And the reason why we're using random forest is because we want to bias random forest in our hard voting algorithm. Okay, so here are the top three variables: time in a histogram and box plot, serum creatinine, and ejection fraction. Note, serum creatinine has 29 outliers. So I also chose KNN and logistic regression. And KNN actually performs quite well when used only with three variables, the top three variables. Logistic regression also does well, but only with the top variable. So the reason why I chose these two is because I wanted to make those algorithms different, but they also perform quite well. So the idea being that we want to bias the random forest. So KNN is a nonlinear algorithm and logistic regression is a linear one. So here's what the code looks like. Note that the implement hard voting section. So all it is that you had to, if you got 2 or 3 votes, then you assign the variable a 1, the input a 1. And if it's less than 2, assign it a 0. And the reason why I had to do it like this instead of using the sklearn package is because KNN and logistic regression and random forest all use different variables from the same data set. Random forest uses all the variables, KNN only uses 3, and logistic regression 1. So then I transformed the variables. I took a square root and a logarithm of them. And serum creatinine still has quite a few outliers, 23 instead of 28. And the ejection fraction, the minimum outliers are exposed. In the paper, they bin the values by month. Now, this is not the best, in my opinion, because we are not looking for explainability of the model, but as they are in the paper, but instead we're trying to get the best measures. So here they are. And you can see that the hard voting plus standardization gets the best measures in MCC, F1, accuracy, and PR-AUC. Hard voting without standardization has the best true negative rate, and random forest still performs well with the true positive rate and ROC-AUC. You might wonder what happens when you do the grid search with hard voting, and it still performs probably just about as good as the random forest algorithm in coming up in 4th place. And that's what that looks like there. Okay, thank you. I've spoken for too long. Hope you're well.